Hey, everybody. Okay, this is section 3 of our hydrosphere unit, our first hydrosphere unit, and just titled this Freshwater Pollution. All right, section 3. So we're going to talk a lot about different types of pollution and how the pollution gets in our water and ways that we can, prevent it. All right. So point source pollution, you don't need to write anything down yet. I've got a lot of pictures in this Google slide. So point source, basically it's exactly what it sounds like. We can actually, if we see the pollution and we actually know the source and basically can point to it. For example, this body of water here on the right is very polluted, and you can obviously point to the source of the pollution because it's coming out of this open pipe. Okay, same thing here. Now, this doesn't maybe look like it's dirty water, but it could be hot water or warm water, which is some things that we talked about in the last section about water quality, which of course that can contribute to a fish kill because the water temperature of the lake or the pond or the river increases and the fish die, insects die, things like that that we need to keep that ecosystem going. Okay, but if we can directly point to the pollution source, that's point source. Okay, but then you have non-point, and it just simply means that we know the water is polluted, but we can't definitely point to the source of the pollution. Did it come from crops? Did it come from a suburban development, like a neighborhood? Did it come from the city streets? Did it come from houses that are out in the rural area or an animal feedlot, or maybe they clear cutted a forest or something? And because there's so much runoff from so many different places, it all ends up in this one water source, freshwater source, like a river, and we can't point to a definite place. Besides, when you're talking about river water being polluted, you also have to remember that rivers span miles and miles and miles through 2 or 3 or more states. So if you're all the way down to the mouth of the river and the water's polluted, it is really hard to figure out where that pollution originated. You can't point to one definite farm or one definite industry because it has come all the way down the river. Okay, so it makes it very difficult. The video links, by the way, I have embedded on the weekly planner. Please make sure you watch them. They're very, very informative, especially the one on well water, nitrates and well water. A lot of you have told me that you're on well water, and I think that you might find that video especially interesting. Okay, but with all the videos, it's a little too long to show on this instructional guide. So I trust that you will watch them. I think there are 4 that you'll watch all of them on your own. Okay. Now, this is a city street. That's a little bit of trash right there. And you see how this all looks so shiny? Well, that's oil. Okay. So that's going into the storm drain, which dumps into our lakes and rivers. Okay. All right. So runoff pollution. Runoff pollution can definitely contribute to what we call the turbidity of water. Turbidity is a very fancy way of saying how cloudy the water is. Okay. We don't want our water in our rivers and lakes and streams to be super cloudy, because then that magical thing called photosynthesis cannot occur because the sunlight can't penetrate cloudy water. And if the sunlight can't penetrate the water, then photosynthesis doesn't occur and the fish can die if it's blocking that sunlight and prevents those plants from producing oxygen, which contributes to the healthy fish and the insects and everything else in that ecosystem. Okay. So to take a look at, and one thing about turbidity. Okay, sometimes if the higher their turbidity, the more cloudy it is. So we don't want it cloudy. So a high turbidity is bad, a low turbidity is good. Okay, so there are certain times where a lake or a river is going to have a very high turbidity. For example, if we have several days of really heavy rainfall, the runoff is going to be really high, because when the banks surrounding that river or lake are saturated from days and days of rain, and all the sediment and dirt is running off and it's going into the lake, it's going to churn up a lot of sediment in the lake, and the lake is going to look really, really brown and cloudy. That we can understand because that's nature taking its course with the rain and the runoff. However, if it doesn't settle, then it finally stops raining, within a day or two, all that churned up sediment has a higher density than the water, of course, so it's going to settle down to the bottom. And then the water should be clear again and have a low turbidity. But there might be a day or two where the turbidity is high. But high turbidity, we don't want that's long lasting, like weeks or months at a time. That is a sure sign that the water is unhealthy for fish and insects and everything else that depends upon it, okay? All right, so these are just some glasses of liquid that show the low to high turbidity. Of course, we want it looking like this one, or even this second glass on the left is okay. But once you start to get dark and really here, that sunlight can't penetrate that cloudy water. So that is not a good thing, okay? All right, now this is an aerial view of a local lake in North Carolina, or excuse me, local river in North Carolina. I want to say that this is Cape Fear, okay, which we've talked about that river basin in the past, okay? As you can see, the turbidity is kind of high. If you take a look very close to the riverbank, that's where it's high. That's not just because it's shallow. That's because this actually was taken the day after a heavy rainfall, and it was purposely done for that, so we could take a look at what the turbidity would look like. So if you look right here along the riverbank, it looks extremely cloudy. Now, another day or two, and it may not look that cloudy, but that's what it would look like from an aerial view. Whereas the deeper the lake, it's already started to clear up here, and that makes sense because the area of water that is closer to the riverbank after a runoff, a severe runoff from some rainfall, that's the area that's going to have a high turbidity because it's closest to the bank where all the sediment is running off, okay? All right, now, these are a little bit deeper waters. This, of course, on the right has a very, very low turbidity, really beautiful, really nice. This one, they actually had to shine an infrared because it was so completely dark. The turbidity was so high, all right, when they took this photograph. But you can barely see some of the underwater landmass right there. And so that turbidity is super high, not a good thing, okay? Okay, another thing that affects the turbidity or the water quality that is carried from runoff are nitrates and phosphates. Now, these are chemicals that are found in fertilizers, especially nitrates. Nitrates are good for fertilizing because we want our crops to grow. We have to fertilize sometimes we have to fertilize our crops so we can have a productive crop, so we can have food to eat. So we need that. We definitely need that. But sometimes the chemicals, they get caught in that runoff, excuse me, and they wash into the lakes and rivers, and they cause algae to grow in large amounts. Now, that's not good because now some fish will eat algae, okay, and we have we need algae in the water, but when we have an algae bloom, and which is a mass amount of algae that grows, algae is a plant, and it will take in the water and the carbon dioxide and produce oxygen just like other plants do. But it can also cause a small body of water like a pond or a wetland or something like that to literally dry up because there's just too much algae and it overtakes that area of water. So we don't want too much algae in our lakes and our rivers. We want the right amount. And sometimes the nitrates and phosphates that are found in fertilizer that runs off from farms and fields, and nitrates are also found in animal waste. that can all promote more algae to grow than we need. So we have to be very careful of that. Now, nitrates can also be found in our groundwater, all right? Not just in our reservoir, but also in our groundwater. And the thing about nitrates is it's not like we can see them and we cannot smell them and we cannot taste them in our water. So they go totally undetected. And nitrates in high amounts are very, very dangerous. So, especially for little small children and infants. So I really, really, really urge you to watch that video that I have linked on the weekly planner about nitrates in well water, because it isn't just well water that they're found in. They can also be found in reservoirs and they'll have the same effect. So you need to definitely watch that, okay? All right, so this is an example, this island, okay, you can see like this is just sort of like a strip of land and you see all that green stuff and it looks so pretty. Well, it's all algae. And what has happened is that what you can't see on the left side of the screen because it's cut out of the picture is a landmass. And the landmass has washed in, all the runoff from that landmass has come into the water, and it has brought with it phosphates, nitrates, animal waste, fertilizer runoff. Everything is in that, and it's causing the algae to bloom, and then it's trapped sort of in this current right here. So it just keeps kind of churning and churning and churning, and it's growing more and more. Now that is way too much algae. That's way too much. So that can really harm the fish and the other insects and other things, the plankton and the zooplankton and the phytoplankton. It can harm all of that because it's just too much, okay? So this is just an animated picture of how that can happen. You know, I mean, we're not going to have just that little tree in the middle of a sidewalk, but you get the idea. We put fertilizer on things and you know, then we water it and a lot of it is going to run off. And if it's really, really close to a storm drain, it's going to go straight into the lake because that water is not treated before it's dumped in the lake. So we have to be very, very careful. I mean, there are things that are, you know, filtered out, some large, you know, trash, things like that. But even that sometimes makes its way into the lake because that storm drain goes straight into the lake or to the river. So we need to be very careful. Urban runoff, the word urban just is relative to a city. So urban runoff has sometimes very high levels of oil, gasoline, trash, things like that. Now that rainbow looks so pretty. Well, that's an oil slick. Okay. So it isn't that pretty, or it's a gasoline spill. And so when the water hits it and, you know, it just kind of looks like it's a pretty rainbow, but all of that is actually going into that storm drain, which again is dumping right into the lake. Okay. So yet there's another video to watch. It's kind of funny, but it's also, you need to take it for what it is. It's very serious because there's a lot of trash that gets dumped in to our lakes and our rivers. And a lot of that trash comes from the storm drains. And so we're not being very good stewards if we're not picking up after ourselves, or even if it's not ours, if we see trash in the road, you know, in front of your home and you think, well, I didn't put it there, I'm not picking it up. Just pick it up. You can always wash your hands later. It's not a big deal. And throw it away, because if you don't, it's going in the lake, okay? Or it's going in, you know, your local river or somewhere, okay? So I want you to take a look at this animated picture, and I will explain it to you. Okay, start at the top left. All right, so because of the trees and the grass and the bushes and it's a park. All right, so when it rains, this is what happens. You have about 10% of that rainfall, that precipitation, that will run off, okay? That will flow off. About 40% of it will just kind of sit there on the leaves of the trees and the grass, and the sun will get it to evaporate. So it goes back into the atmosphere as vapor. There's about 25% of that precipitation that will go deep, deep, deep down into the aquifer, okay? That's below that. You can't, we didn't include the aquifer in there, but it'll go deep infiltrate deeply and go to the aquifer. And then the other 25% will kind of just, it'll infiltrate the soil, but it'll be more the shallow. So it'll just kind of hang out in the soil and water all the grass and the trees and everything a little later when it doesn't rain. So that's a good amount. Those are good percentages. Now, as you move over to your right, what has happened from one picture to the next? Well, took out some trees and some grass, and we added a house. So look at the percentages now. Not 10% like on the left, but now 20% will run off because you have a lot more pavement. And pavement, concrete, and asphalt is not going to soak all the rainwater in like soil will. You'll lose about 38% to evaporation. About 21% will go deep into the ground and, replenish the aquifer. And about 21% will stay, in the shallow area of the ground to water the grass and everything later. Okay? Now, bottom left. You've taken out all the grass and it's more like just 3 houses. Okay? And you've taken out the trees. So now you have 30% runoff because you have more concrete, which is impermeable rock. Okay? The water cannot pass through it. You lose about 35% to evaporation. Only 15% gets down into the aquifer, and 20% stays in the shallow ground. Okay? And then you've got now more asphalt, more concrete. You've got an urbanized area, a whole city around this area. So 55% runs off into the storm drain. 55%. That means all of the oil, the gasoline leakage, the trash, anything, the animal dung that somebody doesn't pick up after. Most cities have laws against that, so that doesn't happen much anymore. But if it did, that would all run off into the lake because it would go into the storm drain and dump into the lake. You lose about 30% to evaporation, but only 5% replenishes that aquifer. And 10% stays in the shallow ground area. So we need, planting trees and grass and things like that is always a good idea. It's always a good idea because, number one, they're pretty, and number two, it does help slow the runoff rate. Okay, it definitely helps slow down the runoff. And that means less will be going into the storm drains. And so less nitrates, phosphates, trash, and things like that will be going into our storm drains. Okay. All right. This is an area that was flooded. Okay. And basically, you have to think of it because once the flood waters, and our fourth section is actually on droughts and floods, so we'll get more into flooding then. But if you take a look at this area, once the waters recede, pull away, some of it will still infiltrate, into the aquifers and the groundwater. Some of it will evaporate, but most of it will run off, or when the water recedes, it's pulling back into the body of water, into the river, which is basically also runoff, but it's going to carry all of that trash, debris, and everything with it. Now, that is an exceptional case because it's a flood, and that's a little different. It's not like we can control the flooding, and we can. So, but that's just to also let you know that that's considered runoff as well. And then there's your video link on the nitrates and the well water, so do make sure you watch that. Okay, industries. The industries, most often, their pollutant that they contribute to is heat pollution because factories are releasing hot water that they use to cool the machinery. Now, more and more, there are legislative acts, there are laws that are being put in place in many states that fine these industries that are just dumping the hot water into the ground or into the lake or something like that. In the last section in our video, you remember us talking about, or in class, you remember us talking about those cooling towers. More and more industries are adding those in, which that's a good thing, okay? Industries, though, do, along with us, the humans, we do produce acid rain. We are the producers of acid rain because acid rain is created when we burn those fossil fuels like gasoline, coal, anything like that, natural gas. When we burn those, they produce carbon, and that, of course, goes up into our atmosphere, condenses with the clouds and the water vapor until it falls in the form of precipitation, which is acid rain, because it's acidic, because it's high in acid, because of the carbon emissions that we have. It's got a low pH, but it's high in it's got a lot of acid because of the carbon that we have been burning with our factories and our cars and other things. Okay, so definitely watch that explanation. It's just a quick 2-minute video by National Geographic about acid rain. But this is basically what happens. You see the gases that are produced through factories, and we really should have cars there too because we produce them as well. So those acidic gases like sulfur dioxide, nitrogen oxides, it's all released into the atmosphere. It gets carried by the wind. So sometimes a factory that's 25 miles from here, we could be getting that acid rain from that factory because that's the acid that clouds shift and wind carries. So the gases that factory 25 miles away produces could be creating our acid rain that falls in Lincolnton. Okay, because that just happens because wind carries those gases, and then again it's going to condense with the clouds, fall in the form of precipitation. They dissolve in the rainwater and they form that acid rain. Now, when acid rain lands on the ground and in our waters, it can kill plant life, it can kill fish, it can kill insects. Take a look at this forest. This is because of acid rain. It has just completely obliterated all of those trees because of so much acid rain. Now, why didn't it kill this tree and this grass and that bush and this? Is it selective? No, not really. It just depends on the actual plant. Adaptation, think about that. Some plants are just better adapted to absorb those levels of acid, while other plants and trees are not, and they die out, okay? All right, bioindicators are key. Bioindicators, and if you look at that STEM bio, you know it means life, and you know what the word indicate means. So these are our organisms that are what I call our super sensitive organisms. They do not adapt to change at all. If they are present in our water, that means our water is healthy. So think about that. Let me say that again. The super sensitive organisms that don't adapt well to change, like a change in temperature of water or a change in oxygen level, they don't adapt well to that. But if they are present in our lake waters or in our river water, that means that water quality is good. It's very healthy. Because if they're not there, that means they're dying out. And that means that your water temperature could be too high, or your oxygen level in that river may be too low. So you want those super sensitive organisms. Usually they're like insects. And if you find those super sensitive insects in that water, that means that the water is healthy. Those are good bioindicators because they indicate that it's a good quality for life in that body of water. But if you don't have those bioindicators, those super sensitive insects, that means that your water isn't of good quality because they're dying. If they're not there, they can't survive. And that means they're dying from lack of oxygen, dissolved oxygen, or the water temperature is too high, or whatever it might be, or there are pollutants in the water. So you definitely want those bioindicators, those super sensitive insects in your water. Okay, so here are some of the good bioindicators. Let's take, for instance, the freshwater shrimp or the stonefly. The stonefly is very common actually in this area of North Carolina, in our North Carolina waters. So if we find stoneflies in our water, that is a really good indicator that water is of high quality. It's pure, it's not polluted, it doesn't have a lot of pollutants in it, it's got good dissolved oxygen levels, there's not too much algae in it, the water temperature is just right, That's what we want, okay? We want healthy water because if you're like people in my family and me, when I get a chance, I like to fish, and I want to know that the fish that I'm taking out of that lake or river is healthy. And it's only healthy if the water is healthy. So we need those bioindicators in our water, okay? All right, here we go. Number 1, sediment or dirt can be considered water pollution in a lake or river. Absolutely, because it raises the turbidity of that water and the sunlight can't penetrate and then photosynthesis can't occur. So number 1 is true, okay? Number 2, hot water is considered a pollution in a lake or river. Absolutely, because if the hot water is dumped into the lake or river, increases that water temperature, it can kill the fish. That's a pollutant, okay? Number 3, most water pollution comes from boats and people on the water. No. Now, most pollution's always going to come from people, but most of it comes from the storm drains, which technically comes from us, but not from boats. Number 4, a large amount of insect larvae in a river indicates poor water quality. No, because insect larva means that the insects are ready to hatch, they are thriving, and that means good bioindicator, good quality of water, not poor, good. And 5, most water pollution comes from land. That is true. Okay, so I hope this helps. If you have any questions, please let me know. Double check, make sure, and I know I've said it 100 times already, watch those videos. They are key. You got to watch them, okay? All right, guys, well, have a great day. And again, email me if you have any questions. Take care.